Hi all from the dungeon. Actually I have the only office with a window, so I'm sitting next to my window. This is a repeat of what we did in class, and hopefully with you pausing and being able to watch this when you're concentrating on maybe writing your own proof will be easier. So this proof is just to provide you another example of a proof that is an if and only if, and it also brings in the definitions of divisibility and greatest common divisor. So A and B are integers in this problem, and the problem is to prove that the greatest common divisor of A and B is equal to A if and only if A is divides B. So just to clarify, the stick here means A divides B. This is the symbol that is used in your book for greatest common divisor. And in fact, some books don't use the GCD in front. They will drop the GCD and you'll just have ordered pair. I'll shut off the... And once in a while you'll see me use the IFF, if and only if. It's shorthand for if and only if the words. So first we need the definition of GCD, otherwise we have nowhere to start. So let's look at that. On page 271 they have the definition of GCD, and in many books this is not done in a concise way. Maybe in number theory books you see it more concisely done. In your book they're a little bit loose about it. They first define what's meant by a common divisor. A common divisor is a number that's not zero that divides both A and B. Like, for example, 2 is a common divisor of 4 and 8, because 2 divides 4 and 2 divides 8. Something's the greatest common divisor if, in addition to being a common divisor, so it divides both A and B, C has to be bigger or equal to D. It's the biggest one of those that divides A and B. So in the previous example with numbers, 2 divides 4 and 2 divides 8. It's a common divisor. It's commoner. The greatest one of them all is actually 4, because 4 is bigger than 2, and 4 is probably as big as you can get. 4 actually is an example of this theorem that we have here that we're trying to prove. So the first step in an if and only if is that you really have 2 distinct proofs to write. And I don't think that was clear on the homework. You really have 2 separate proofs. They may have something to do with each other, they may not. So the first proof you have to write is if the greatest common divisor of A and B is A, then A divides B. The second proof you have to write is if A divides B, then the greatest common divisor of A and B is A. And I say the proof you have to write because to me, when someone says if and only if, they're just being cute. What really they're doing is they're giving me 2 proofs to write. So let's start with 1. Let's fill out the proof guide for number 1. What's my no? Well, I extract the words between the if and the then and just copy and paste. The greatest common divisor of A and B is A. So what does that mean? Well, I'm going to call C this GCD so I don't have to deal with writing GCD all the time. It first means that C is the common divisor, so C divides A and C divides B. And the second thing is that it's the biggest of all common divisors. The real nugget or the real piece I can use in anything is right here. Oftentimes, if I have something like GCD and I need to prove something, I'll start with this first nugget. And if it doesn't look like I'm getting to the end, what I'll do is I'll go to the second piece right here and try to work that piece in. Expanding that nugget I just extracted tells me that C divides A means that A is C times S, and C divides B means B is C times T for some T and S that are integers. Those 2 pieces are nuggets. So that's expanded as far as I can. I'm going to toss those 2 nuggets to the side. We also have that the greatest common divisor is equal to A. So we also have that C is equal to A, and that's a nugget. So those 3 things are the things I can use to get where I want to go, which is that A divides B. Well, if I look at these 3 things I have here, I just get a feeling of automatically putting C equals A into this one. And I get a new nugget. I get B is equal to A times T. So I just did that just because I saw them all sitting there and it looked like it was crying to do that. I'm supposed to show A divides B, or that B is A is a multiple, or B is equal to some multiple of A for some integer V. I'm done because I have it. See, in this nugget over here, my T is V. So from my know, I immediately can pop out my show. I'm done. My V is T. So that was pretty confusing. So let's do a Dr. M polished proof, which you would accept. What am I given? What's my know? The GCD is A. By definition, a common divisor, A divides A and A divides B. Or I'm taking out the only nugget I really needed, B is equal to A times T. And that disappeared. So what we're going to do is we're going to see if we can copy that. See if I can copy that. So by that nugget that I just extracted, I'm supposed to show A divides B. That's true by definition of divides. I automatically have it because this part here already told me that A divides B. So I'm done. Okay, so the other direction, proof number 2. Proof number 2 is that if A divides B, then the GCD has to be A. So what's my know? My know is A divides B. That means B is equal to A times T for some integer T. What is it I need to show? Well, I first need to show that A is a common divisor of A and B. And the second thing I need to show is that it's the greatest of them all. So I have a little trick. I let C be the greatest common divisor of A and B. I'm allowed to call it anything I want. And then I take out the properties of C, which it was just a name. The property is that C divides A and C divides B. And I write down what that means. C divides B means that C is equal to B times S for some S. But my know is that C is also equal to A times T times S. So all I did is I took the know and I substituted it in. And a lot, these are called these are basic number theory proofs. A lot of the times all it is just substitution, at least the easy ones. So C is equal to A times T times S. But C divides A gives me A is equal to C times U. So if I do another substitution, I get this. Get this equation. So I'm just substituting my knows into different pieces. What that tells me is these are all integers. That must mean that U times T times S has to be 1. Otherwise you won't get that inequality because I'm working with integers. But that must mean that U, T, and S are a combination of pluses and minus 1s. If I go back to this thing right here, it means that since C is a positive number, T times S either has to be both plus 1 or minus 1. It doesn't really matter, because in either case, that forces, because T times S is 1, it forces C to be equal to A. And that, I was supposed to show the greatest common divisor was A. I'm done. The greatest common divisor is A. I've reached where I'm supposed to reach. So this might have been confusing, because it's not all on one page, it's on different slides. Go back, pause, watch this again. A lot of proof writing is looking at done proofs and seeing the details and seeing where they came from, and then struggling with them yourself. So that's what makes proof writing a little bit more different than integrating by substitution, let's say. So good luck.